Hello everyone. So I decided to create this LeetCode profile that I have here, and I've created this, and I want to record the videos in order for preparing people for their coding interviews. Now, at my job when I first started, uh, I got very interesting problems, and I decided that I was not prepared enough, even though I got the job, and my idea is to go through a lot of these questions and actually try to solve them, and of course document it in order to help everyone else who wants the same thing as me. So I'm planning on starting with the easy questions first. Now the easy questions first, I don't know how easy they are, medium and hard. But usually when we go from easy to hard in these, since I was using, I forgot what platform I was using. It was not LeetCode. It was something a bit more practical. It doesn't matter. So the easy problems, they're having some aspects that you need to learn, and in the medium, you just continue developing on them. So for example, the backtracking algorithm requires you to know recursion and lists, right? And the easy ones are going to teach you these. So let's start with twosome, the first one. And now, so public class solution. We're gonna do this in C#. Now I was planning on doing it on JavaScript as well. I'm gonna see if, okay. You need to solve at least one question. All right, I'm gonna do that. So the next video is probably I'm gonna do it in JavaScript since I want to learn it as well. So let's actually read. Whenever you are into a job interview, you want to be sure that you understand what exactly is it that you are asked to do. So read it very carefully. And here in LeetCode, we have examples. You can see every problem has one when you're doing it offline, right? Not in the job. And then you have hints and then some questions, and you have related topics, right? So let's actually read the problem now and start developing a solution. Given an array of integers nums and an integer target, return indices of the two numbers such that they add up to the target. All right. You may assume that each input would have exactly one solution, and you may not use the same element twice. All right. And you can return the answer in any order. So from this description, the only thing that I haven't understand correctly is you can return the answer in any order. So for example, here 0 and 1, I suppose that 1 and 0 is also going to be valid. We can actually check that. I'm going to check it later. So 2, 7, 11, and 15, and our target is 9. We return 0 and 1 because 2 and 7 are the ones that are adding up to the target. All right, seems pretty easy. Here is going to be 2 and 4, and here's going to be basically 3 and 3. And by the way, they said you may not use the same element twice, and here they're using the same element twice. Probably they mean the same element, not the same value, right? All right. So, couple of ways that we can actually do that, and let's go to Paint. I'm gonna start explaining my algorithm, and then we're gonna start to code it. All right. So I don't remember the exact numbers, but I'm gonna write a couple of numbers, and I'm not gonna put 2 and 7 in the beginning. I'm gonna put 11 here, 15 here, and then I'm gonna go with 2 and 7. I'm gonna show you why. So left click on green, and then I'm gonna put right click red, right? Just so I can show you. So it's very beginner friendly. This problem is actually very easy. So we're gonna have 2 pointers, and we're gonna start here with the first one and here with the second one. So the second one is always going to be 1 up front, since we are not able to use the same element twice, right? So I cannot, if I'm searching here for 22, I'm not going to return 0 and 0, right? That's what it means. I'm not going to return 2 times 11 because that's going to be, I guess, too easy. So what I'm going to do is I'm going to test, is 11 plus 15 equal to our target, right? So I'm going to say t. And our target is going to be 9, so I'm just going to put this here in brackets. And the answer is no. So I'm going to, until I reach the end of the list, I'm going to increment the second pointer. 11 plus 2 is equal to 13, so that's not going to be it. 11 plus 7 is going to be equal to 18, so that's not going to be it. Once I actually have everything figured out, I'm going to move my first pointer one step further, and my second pointer one step further. So now I'm going to be testing if 15 plus 2 is actually equal to target. The answer is no, so I'm going to move target, not the target, but the second pointer one step further. And I'm going to be testing if 15 plus 7 equal to target, which is not. And we are in the end of the list. Increment the first pointer again, and we have, is 2 plus 7 equal to target? The answer is yes, so I'm going to return, what is this, 0, 1, 2, and 3 as an array. All right, so that seems pretty much it. Now the only problem is that, well, I don't know if we'll have time to optimize it, but our time complexity, right, is going to be n squared, and our space complexity, of course, is going to be linear because we're not doing anything, right? So if I need to write the mathematical function of that, oops, for some reason something bad happened. Okay, it's going to be like this, right? So it's going to be whoop, linear, and this is going to be our time, and our space is actually going to go like this, right? Because it's not getting okay, not exactly this one, but you get the idea. If I remove that. All right, so that's the solution. One thing that you can actually do better is to put a hash table, but we're not going to be talking about the optimization just now. Let's try to code this up and see what we're going to do. Back to the LeetCode. All right, so we are in LeetCode now, and I don't have Paint by my side, but I kind of remember what I want to do. So the first thing that I need to do is create an array to return. I can just do list for that. We'll figure it out. The next one is that of n time. This is going to be good enough for me to remember. And the next one is going to be just returning. Yeah, I don't even need to write that. All right, so create an array to return. What I'm going to do is I'm going to create an list int. So I'm going to say return, or I'm just going to say output array is going to be equal to a new list of ints. And that's pretty much good to go. And what I need to do now is I need to go and do the first loop that I was talking about. So in order for me to do the first pointer, what I can do is I can say for, and I'm going to say first pointer here is going to be 0. First, why can't I write? First pointer is going to be less than nums dot. Is this what I want? I'm not entirely sure, but let's actually check it out. And the first pointer is going to go forward, right? Now, in order for me to get the second pointer, what I need to do is to start one step further. So I'm going to say second pointer is going to be equal to first pointer plus 1. Second pointer is less than nums dot length, and now I see the error. Second pointer plus, and I'm going to do this, and let me just do that. Okay, good. So here I'm going to do -1 because otherwise we're just going to go out of the array. So we have the first pointer, we have the second one, which is going to be the second. And what I need to do now is just test. So I'm going to say if nums of first pointer plus nums of second pointer, if this is equal to our target, right? I'm going to say output array dot add, and I'm going to add first pointer, I'm going to add the second pointer. Oops, not like that. Control D, does it work? It doesn't. So I'm just going to say output array add second pointer, and that should be it. So I'm going to say break. Okay, good. So that's pretty much it. Since we have only one solution, I'm not going to be bothering searching for more. I'm just going to break here. And now I need to return the output array. And since that is list, I'm going to say .toArray here. And that seems pretty legit to me. So if first pointer is 0, less than length -1, yes. I'm going to increment the first pointer. I'm going to increment the second one as well. This one is going to be the first pointer plus 1. So the second element, second pointer is all right. All right. So let's actually test it out. Run and code. So run code result is going to run the code results with good. So it works with this. Now you can say use example test cases, and you're going to use these examples over here. And when you submit, you actually run it into the server with a bunch of other tests that you can fail. So let's actually run them with the 3 tests that we created, that we have as an example. Seems to be working. And now I just need to probably remove my comments because I don't want them to be here. Can I optimize something before I actually submit, since that is going to run a lot of tests? I want it to be as quick as possible, but I don't really see. Yeah, I can just put array here probably, but it's gonna be all right. Okay, good. Let's submit and see if we made a mistake. Hopefully not. All right, good. So there it is. Memory usage, we're using a 42.7 megabytes of memory. We have a success, and now you can actually go into details over here and you can see what is the quickest methods. So you can actually go to the quickest and you can see that they're using a dictionary, which is something that we're going to be covering in the next one. You can see the same algo here. Just comment it out and then run with dictionary. All right. Now, whenever you actually go into an interview and you get a question like that and you do it this way, what you want to say afterwards is, I do realize the time complexity, which is going to be a bit more mathematical. I'm not going to get into it. It's not as difficult. It's just big O of n squared. Since we have 2 for loops, right? One below the other. And if you think about it, you're going to have quite a lot of iterations. Now, I'm going to show you probably the math later on if someone is interested. But usually, if you have a 4 under a 4, it's safe to say that it's n squared. Not always, but usually. Space complexity. So we did have a good space complexity, and it is because we're not using a dictionary, so we're not wasting any memory. It's just linear. I don't even know, by the way, who has the better memory usage of us. I really don't understand. So here is the memory usage, and here is the best one. So if I click that, I can't even click it, but let's click better one. And you can see that, yeah, they're using an int, so they're just returning new int here. They're not creating an array, they're not creating a list over here, they're just returning this. And otherwise they're returning, actually that's pretty smart. Yeah, I like that. That's a good idea. That's why the memory is better. It doesn't matter, however, it's still linear, right? Because we're just creating this list, and this list is going to be 2 items always. And a very important note to ask is, do I need to optimize this, right? If they say that you need to optimize it, then you're going to think of another algorithm, but you already have something working out. So you already have something figured out, and it's a lot more easier to actually start from here instead of go for the optimized solutions from the beginning. So here, if you go to related topics, you can see an array and a hash table. And in the interview, they're not going to tell you how to optimize it, obviously, but you can ask them for hints, and you can ask for, what kind of a topic am I looking into, right? Am I looking for a stack? Am I looking for a heap? What exactly am I looking up to? And here, the follow-up of the question is, can you come up with an algorithm that is less than n squared time complexity, right? Which is not this one. So next, we're going to do it, the optimized algorithm, and it's going to go linear time and linear space complexity, but you have to suffocate one for the other. Right, thank you for watching. Like, subscribe if this has helped you, and a lot of other interesting problems are coming, so I hope you stay tuned. Let's just give a like here. You give a like to my video as well. Bye, guys.